participants. Welcome to the final day of a one-week online FDP on antennas for 5G communication and beyond. And today's topic is antennas applications in wireless communications, a research perspective. And myself, Dr. K. Vishnuvardhan Reddy, Associate Professor in the Department of ECE, Aditya Engineering College. I am delighted to introduce today's speaker, Dr. Jagdish Babu Kamili. He was born in Chirala, Andhra Pradesh in 1978. He received his BTech degree from SVH College of Engineering, Machilipatnam in the year of 1999. MTech and PhD degrees from JNTU, Hyderabad in 2006 and 2013 respectively. Also, he is a postdoctoral researcher under Certificate of Excellence in Research program from Indian Institute of Technology, Kharagpur, India. Presently, he is working as a professor and head of the department at St. Anne's College of Engineering and Technology, Chirala, India. He received travel grant from SERB, Department of Science and Technology, DST, India, to attend the international conference PIERS 2017 in Singapore. Also received funding from AICTE under RPS scheme. Thus far, he executed projects worth 3 million rupees. He received Best Researcher Award from JNTU Kakinada University in the year 2018. He is a senior member of IEEE and life member of IE and ISTE India and fellow IETE. He published nearly 50 research papers in various reputed journals and conferences. His research areas include printed antennas, 5G antennas, dielectric resonator antennas, metamaterials, ground penetrating radar, and characteristic mode analysis. Thank you very much, sir. We welcome you to conduct this today's final session on uh, antennas applications in wireless communication, a research perspective. I request Dr. Jagadish Babu, sir, to continue his session.
Right. Thank you, sir. Thank you, Dr. Vishnuvardhan Reddy garu. Thanks for your brief introduction about me to the participants.
Thank you, sir.
Firstly, I would like to thank the management, principal, and head of the department, Dr. N. Radha garu, and my colleague friend, Dr. A. Tatababu, for giving me this opportunity to participate in this eminent faculty development program on these 5G technologies from your reputed organization. Thank you, sir. Thank you. I hope the program will be definitely rejoiceful, and the participants will get some glimpse about the 5G communications, as well as about the importance of designing better antennas for 5G communications. Right now, I would like to share my presentation. Right, sir. I just shared my PPT. Are you able to see it?
Uh, we are seen. I think your Yahoo mail was open, sir.
And I just shared PPT also.
Yes, sir. Today, now I can see the
Right, sir. Right, sir. Right. Thank you.
presentation. Okay.
Right. Good morning, everyone. Today, my topic of presentation is antennas and applications in wireless communications, a research perspective. Right. So, in these 2 hours of presentation, mainly I'm going to discuss these 5 points which I have given here in this slide. First, I will start with types of communication and how the communication has evolved from 1G to 4G technology, and what is the need of going for this 5G in the present current trends of wireless communication. These 3 parts will be the first part of my presentation, and during the second part of my presentation, I would like to discuss about the interesting concept, that is the scope of research in the field of antennas, as well as design challenges in antennas for 5G technology. So in brief, these are my presentation details. Right. Now I would like to start with just basics of communication. So we know communication means the process of conveying information from one point to other point, or the process of conveying information from source to destination. Actually, we feel that communication means it can be achieved only by means of mobile phones or TV or landline, etc. But actually, communication, it has its own significance since aeons back. Even thousands of years back, also, we had our own means of communication. Because what is communication? Simply the process of conveying information from one location to other location, or from one means to other means. So, briefly, this communication we can categorize into two ways. One is we can take it as traditional means, and second one we could take it as electronic means. So traditional means is the means of communication we have used before the developments in science and technology. And here in these traditional means of communication, we are having various methods like non-verbal, verbal, and by using different animals or objects like smoke, pigeons, horse, etc. What they are just I will show you in a few slides. And the second means of the communication is electronic means of communication. So with the advance in our developments in science and technology, gradually as our scientists, they have developed this uh, concept of electron and the methods to transport this electron from one location to other location. Gradually we have developed the means of communication like telegraphy. Around 1832, the first means of electronic communication was invented by Samuel Morse, using that Samuel Morse code. We all know about it. There is telegraphy. And after telegraphy, we are having gradually it has evolved into telephony. And after telephony, next with the inventions from Henry H. Marconi and James Clerk Maxwell, we slowly entered into wireless communication. And again, this wireless communication, how it evolved from 1G to 5G, just briefly, I would like to show. Right. First, I would like to uh, present few slides regarding this traditional means of communication. So here, the thing is, I would like to tell my presentation. It's more like storytelling. I don't want to involve some complex mathematical equations, some technical jargon like that. I don't want to present. So these 2 hours of presentation, I want to be more interesting and rejoiceful to the participants. So it's like more like storytelling. At the same time, I want to give some glimpses of this 5G communication as well as antennas. Right. First, non-verbal means of communication. So non-verbal, there is no voice here. So I have shown you here a few examples of this non-verbal communication, like using smoke signals, drums. Here, these are also a means of communication. In the olden days, before the development of science and technology, means when we are having a king's kingdoms, when they want to communicate, they have used these smoke signals, drums, etc. Suppose some enemies, they are entering into a kingdom. Then at the border, the soldiers will be there, and those soldiers, they have to communicate with the soldiers in the palace. Of course, now we are having mobile phones, satellites, etc. But in the olden days, they don't have such means. So in what way they can communicate? So at the border, they lit some smoke. And again here, there are some codes. Suppose if there is one smoke burning, there is no danger. If there are two smokes at two different places are burning, then there is some danger. And there are three or four, the danger is more. Like that, they will be having their own coding in the smoking. It is also a means of communication. And here I want to tell you, there is another means of communication. Even nowadays, it is being used in some villages, drums, by beating drums. Of course, in our local language, we call it as dandora. By beating drums also, we can convey the information. There are some rural villages where if they want to communicate the information, by beating these drums, which we call as dandora, they used to communicate the information. Similarly, in the olden days also, during the time of kings and kingdoms, whenever they are going to start some war, they will beat drums. Of course, these things we have seen in so many movies, Bahubali, etc. So it's also a means of communication. Next, as man has evolved gradually, from Homo sapiens, gradually he started using his speech signal, like the methods of storytelling and using a natural speech. They used to communicate. In verbal communication, even now we can find there are some caves found in some countries. On the caves walls also, they have painted to communicate the information to their some information. It's also a means of communication. And next,
Sir,
another means of
excuse me, sir.
communication. Yes, madam. Am I audible?
Yeah, sir, you are audible, but the slides are not being changed, sir. It is
Slides
at
are not.
the starting slide.
Madam, now
In,
which slide
on
you
my
are seeing,
side.
madam?
On my side, I am able to show first slide. I am able to see first slide only, sir.
First slide only. So, what about other participants? Now, presently here I am showing pigeons and horses slide.
No, sir. First
Sir,
slide
please
is
share the full screen, sir.
But
Because
sir,
I get
for me
to-
also only the first slide is visible.
Oh,
Yes, sir. Now it is visible. Pigeons and horses.
Yes,
pigeons
sir.
and horses.
Yes, sir.
Okay, right.
Okay, sir, but it would be better if you are going for the presentation mode, sir. Please press F5.
Yeah, presentation mode. Now, is it okay?
No, sir. You please
Yes,
select
sir.
full slide.
Yeah, now
mode,
I went
sir.
to the presentation mode.
Sir, slide show.
Sir,
Or press F5, sir.
right, sir. Actually, I know I'm doing it. Actually, here on my laptop, I'm having it only, but I don't understand why you are not seeing that.
Sir, now it is moving, sir. No problem, sir.
Okay, now are you able to see my presentation mode?
Yes, sir.
Right, good. Thank you. Right. So here, pigeons and horses, they are also one mode of communicating the information. Actually, interestingly, these pigeons are having one magnetoreception, which our human beings are not having. With the help of that magnetoreceptions, these pigeons can move around the Earth globe with the help of Earth's magnetic field, and they can travel hundreds and thousands of kilometers to convey information from one location to other location. So here it is also a means of communication. And then next one is horses. Throughout the world, in so many countries, for many of the years, the best means of communication is using horses to convey the information. And here I would like to important thing. Around 2019, I have seen one article in IEEE Antennas and Propagation magazine. There, they have mentioned that in Holland, they have developed the means of ham radio to convey the information with the help of horses. Means even nowadays using horses convey the information from one location to other location, and with the help of ham radio. I hope you people, you may be having some glimpse about the ham radio. So using ham radio, we can develop our own communication. So especially here, we have to no need of buying any spectrum. If we have to write some written test, if we are qualified, we will be given some license so that we can use this ham radio. Of course, some of the film stars are also having this license, like Kamal Hassan, Nagarjuna. They are having this ham radio license. And the thing I want to tell, during the time of Hudhud Tufan, around 2014 in Vizag, this ham radio helped a lot for many days, because because of that Hudhud Tufan, for several days there was no power. There was no power. There is no means of communication. And using this ham radio, they were able to communicate information from one location to other location. Here, using this ham radio, presently they started communication and fine. These are all, we can call them as a traditional means of communication or crude methods of communication. Slowly, as we have evolved, and with the findings in technology, in electronics, we started using electronic means of communication. So the first means of electronic communication is telegraphy. Yeah, one thing here, I am showing my presentation regarding telegraphy slide. Are you able to see, madam? My presentation slide is about telephone and telegraphy.
No, sir.
Hello,
Again, it is showing pigeons and horses only.
Pigeons and horses.
Okay. Now?
No, sir. Yes, sir. Yes, sir. Wired telegraphy and telephony.
Yeah. So when I'm going into presentation mode, the slide is not moving for you people. I don't understand. Anyway, I will continue. Right. So here, the first means of electronic communication is wired communication is telegraphy. It was developed by the great Samuel Morse in the year 1832. We know each alphabet there will be some code, like a dot in the form of dots and dashes. Those dots and that was the first means of communication. And almost all during the time of First World War and the Second World War also, we were having this means of communicating the information. And around 1876, Alexander Graham Bell, when he has developed this telephone, they started the direct means of duplex communication. Actually, Morse code is only a simplex communication, and the telephone, is a full duplex communication. Means at a time you can transmit the signal and you can receive the signal. So we are able to speak, we are able to listen. This Alexander Graham Bell, when he has developed this telephone, of course, he has uttered the first word about hello. Of course, in the internet, there is a saying that the word hello, it was first used by Thomas Alva Edison, but still we don't know. It is a matter of controversy. The word hello, which every day regularly we are using, it was first used by Graham Bell or Thomas Alva Edison. Still, it is a topic of discussion. Right. Now I have moved into another slide that is about 1G communication.
Yes, sir. It
Here
is visible.
we are having. Okay, thank you. Right. The first means of wireless communication. Morse code telephony, actually, they come under wired communications. But we know the drawbacks of these wired communications, because there are many constraints out there. It is constraint and cause some drawbacks. And with the inventions and discoveries from our scientists like Henry H. Marconi, and legendary James Clerk Maxwell, with their contributions to this electromagnetic theory, slowly we started or we have entered into wireless era. This wireless era, it is broadly classified into G's. G means generation here. We start with 1G. Presently, we are in the generation of 6G, but of course, in India, still we are at beginning of 5G, and the remaining world, they are moving towards 6G. So we shall see gradually what are these Gs. First, 1G. This is the technology. It was developed around 1980s. And in the main characteristic of this 1G is it basically uses analog signal. So as it uses analog signal, here there is no question of having speed, and it gives the data only in kilobits per second. And it can give a maximum data speed of 2.4 kilobits per second. And of course, there are several drawbacks. As it uses only analog means of communication, the drawbacks are poor voice quality, and then phone size is large. In the olden days, we can recall the size of the phones. Phone size is large. There is no security, because security we can get only in digital communication. As it was based on analog, there is no question of security, limited capacity, and a poor handoff reliability. Handoff. What is handoff also? Just I will. These are some limitations of 1G. And this was the technology initiated around the 1980s. Next, 2G. 2G technology, it started around 1990s. And one of the important characteristic of 2G is it uses digital signals. From 2G onwards, we started using digital signals. As it uses digital, obviously the data speed is improved. Now it has improved from 2 kilobits per second to 64 kilobits per second. Of course, in our India also, some around 10-15 years back, we have used mobile phones. And in the beginning of our mobile phones, the technology we have used was 2G technology. And the type of services it can offer is we can send picture messages, MMS, etc. But there are several drawbacks in this 2G technology. The 2G technology, it cannot handle video signals. This is one of the main constraint of 2G, because its speed is, its bandwidth capacity is only 64 kilobits per second. So it cannot handle video signals. But there is no question of having a network coverage in any specific area, and it cannot have strong digital signals. These are some of the drawbacks of this 2G technology. And then we started gradually, and we have proceeded into 3G technology, which was started around 2000. Now I'm showing a 3G slide. Here in 1G and 2G, the speed is around kilobits per second only. And around some 5 years back, the technology which we have used in our country, all the mobile phones, they are purely based on this 3G technology. Of course, some 5-7 years back, what are the features? The data speed we can handle up to 2 megabits per second. They are called as smartphones. And important characteristic of these 3G technologies, we can send or we can handle video signals, and even we can go for video conferencing, 3D gaming, and it can give large capacities, etc. But still, though we can send video signals, though it is comparatively, it is of high speed compared to 1G, 2G, still it is having its own demerits. That is speed again. That is, its maximum speed it can deliver is only up to 2 megabits per second. And apart from that, there are several drawbacks which I have mentioned here. Like, it requires high bandwidth, and they are expensive. 3G phones were in the beginning of the days, they were expensive, and the license services are also expensive. Like that, there are several drawbacks. Presently, in India, the type of technology and the mobile phones which we are using is this 4G. Now I am delivering some lecture, and most of the participants they are following this lecture using their mobile phones, which is based mainly on using this 4G technology. This 4G technology actually it started around 2000, but in our country we started using this technology around some 6 to 7 years only. And coming to the data speeds of this 4G technology, its data speed can be up to 100 megabits per second, and even it can go near gigabit per second. Using 4G technology, having 1 gigabit per second is the only ideal case. Practically, it was never achieved. Using 4G, what is the maximum data speed we can get with our mobile phone? Around 100 megabits per second, or 200, or maximum 50, 300. That about the speed. And there are several other benefits, like it is more secure, high speed, high capacity, and 4G it is called as magic. Magic here, what it represents is M stands for mobile multimedia. So we can go for multimedia using mobile itself, and then anytime, anywhere. Because this technology, the main advantage of 4G is network coverage compared to 2G, 3G. One of the characteristic or striking advantage of this 4G is network coverage. So it's called as anytime, anywhere. And next, global mobility support, integrated wireless solution, customized personal services. This 4G technology, it offers customized personal services. Means I can have my own applications using the using this 4G technology. But still, though it is having its plenty number of advantages, there are several drawbacks of this 4G technology. Like massive IoT cannot be implemented. Okay, we all know presently it is the generation of, or it is a trend of IoT. The trend of massive IoT. So massive IoT means millions of wireless devices, they are to be interconnected. So to interconnect thousands and millions of devices, this 4G technology's capacity is not sufficient. This is one of the main drawback of 4G, and having the ability to connect massive IoT devices is the one of the striking advantages of 5G, which I will discuss later. And we can see another drawback of this 4G technology is it can handle data up to maximum is 1 gigabit per second. Still, it is ideal rate only, and of course, it requires complicated hardware, and it also like 3G. It also requires some expensive equipment. So these are all about 1G to 4G. In this slide, I would like to show just a comparison features from 1G to 4G. So now the slide I'm going to show you from 1G to 4G. How about the speeds? So if you see 1G, the person is just kneeling down with the speed of 2.4 kilobits per second. And in 2G, it has slightly increased. Still, it is in kilobits per second, 64. And coming to 3G, 100 Mbps, and even it is 200 Mbps. And coming to 4G, we are able to achieve up to 1 gigabit per second, ideally. And here the tap figures they are showing the speed. We can see of this 1G to 4G. These are the technologies we have used thus far. Now here I'm going to show you some glimpses regarding the present technology and also the future technology, that is 5G. Right. Now I am showing a slide related to introduction to 5G. Okay. Right. What's 5G? This is the technology 2020s, and India just now the steps are being taken to make this technology into the daily use. Actually, if there was no corona, already we would have used this technology since 2020s. It got a little delayed, and soon we are going to use this 5G, and already in some of it takes several months, maybe, or within 1 year. Most of the mobile phones which we are using throughout our India, they will be mostly they are based on this 5G technology. Okay, right. Nowadays, everyone is saying 5G, 5G, 5G. Okay, why this 5G is highly beneficial compared to earlier technologies like 4G and 3G? Let us see. The main feature of this 5G is this is used not only to interact people, not only for mobile communication. It is having its several interesting advantages. Using this 5G technology, we can interconnect and control machines. To interconnect machines, the suitable technology is 5G only, because whenever you are interconnecting some devices, objects, and you want to control them, their speed matters. We know in 3G or 4G, the speed is up to megabits per second only. So that megabits per second data speed is not sufficient to control the devices or to control the machines. In such case, definitely we need the fastest technology, which is nothing but this 5G technology. Here, this 5G technology, it is expected to deliver some new levels of performance and efficiency, so that the user can experience. Obviously, the main feature of this 5G technology is speed. The beginning speed of this 5G technology is 1 gigabit per second. And here our is per second. Presently, they were successful in giving speed up to 20 gigabits per second, but in future, we may get speed up to 100 gigabits per second. Here we see some of the advantages. So main advantage of this 5G is high speed, and next high capacity. It provides a large broadcasting of data in gigabits per second. This one we can use for multimedia and high definition quality TVs. And it is more effective and more attractive in the especially in interactive media. Interactive multimedia. What is that interactive multimedia? I will show you in such cases where speed is the main criteria. Here we can go for
Sir, your voice is breaking.
Right. So now, madam, is it okay now?
Sir.
Hello. Is it okay,
sir,
madam?
now it is okay. Yes, sir. Yes.
Okay. Right. Okay, madam. If voice is not clear or if the slides are not moving, please let me know. 5G potential realizations. So here I would like to show some of the important applications where this 5G technology can be used. So one of the application I would like to show is remote surgery. Nowadays, doctors they can do surgery in Hyderabad by getting instructions from a topmost surgeon somewhere who is in UK or US. So there, the doctor in US or UK, in the video mode, he gives the instructions, and with those instructions, here in the local place, the doctor can do the surgery. So in such cases, there are several things important. One is latency. low latency. Latency means delays in network. That is very, very important. Means they almost 100% live streaming we are required, and high speed, because the in US or UK, very high clarity in video signaling. All these things are very essential, and these things are not possible using 4G, whereas this is possible with the help of this 5G technology. And next, we are having a few more applications. Industry. Almost all throughout the world, you take the industries, and next, especially automobiles. Already Tesla, we know, they have launched these self-driving cars or humanless cars. Already they are in use. Here in self-driving cars, the important thing required is accuracy as well as speed, because in a fraction of second, suddenly cases, very in a short time, it has to take the decision. So there the time is important. It means low latency important thing.
Sir,
Virtual here.
again,
Yes,
sir,
in
your
future slides I will
voice
show
is
you.
breaking. Sir.
Voice is breaking. Okay.
Sir, hello. Sir, please unmute your mic. Hello.
Right, sir. Sir, am I
Yeah,
audible now?
Yeah. Now okay, right.
Right. Thank you. Right. So here, these are some potential realizations of this 5G technology. Next, as I mentioned, speed offered by 5G. Presently, the target speed is 20 gigabit bits per second, and in future, the target is our researchers and scientists. They have aimed at delivering the devices that can handle up to 100 gigabits per second. Presently, the Qualcomm, they have achieved up to 5 gigabits per second. See, 5 gigabits per second means that speed really we cannot imagine. Even 1 gigabit per second is a very high speed. 1 gigabits of information we can transmit or receive within a second. Means a high definition movie within a second here we can download. Presently, using this 4G technology, if you want to download a movie, it takes few minutes, maybe some 8 minutes or 10 minutes. But within a second, we are going to download one high definition movie. So that is the striking speed offered by this 5G technology. And apart from that, it gives higher peak data rates, more network capacity, and it provides the huge spectrum, etc. Right. Now we can see a few of the benefits of this 5G technology. As I am telling, it is the future technology, and there is one prediction up to 2040. We are going to use this 5G technology, and after 2040, another future technology will come, that is maybe 6G, 7G, etc. But till 2040, the type of technology we have to use is this 5G technology. And you can look at the third bullet. By 2035, it can offer a huge developments in industrial side, producing up to 12 trillion worth of goods. So, and also it will provide millions of jobs, and there is a prediction it can provide up to 22 millions of jobs in this 5G communication. So there is a huge trend in this 5G wireless communication. So 22 million jobs will be based only upon this 5G technology throughout the world. So it is definitely, it is the present and future technology. Right. Now we can see the performance targets. So peak data rate or the target data rate using this 5G is 50 gigabits per second, and anywhere 1 gigabit per second. This is important. Anywhere. Having peak data rate is not important actually. Anywhere throughout the network coverage, what is the data rate we are going to attain? That is the important factor. For example, here you can see the last point, last bullet, which is given in a green color. 4G is actually cell edge technology, whereas 5G gives uniform experience, right? Cell edge. So we know what is this cell edge. If you go to the edges of the mobile network cell, there at the edges, we will get poor signal. The signal is not uniform. That is one of the drawbacks of this 4G technology. But the ideal case of this 5G is the user will experience uniform speed and uniform coverage throughout the network cell. That is one of the important features of this 5G, which is not possible with 4G. And the target in 5G is having uniform experience throughout the coverage area. That is another important point. And the next important thing is latency. Latency, it is less than 1 millisecond. If you take 4G, the latency is even up to 100 millisecond. But of course, presently we are having some 20-30 millisecond. But using this 5G technology, the latency is aimed at giving less than 1 millisecond. In most of the crucial applications, this latency, it plays a very important role. We know latency means simply the delay in the network. To make a call or to pick up the call, the delay, we can call it as latency. So it is expected to be less than 1 millisecond in this 5G technology. Right. Okay. Here in this presentation.
Excuse.
Yes.
The slide is not being changed. It is, I can see 5G potential realizations slide only, sir. It has been stuck to that.
Madam, it is moving now.
No, actually, I am showing
It's moving.
Yes,
now,
three
no
pillars of
problem.
5G.
3 pillars of
I
5G.
think maybe you can
Right,
leave
right,
and
thank you.
rejoin,
For
madam.
5G, no problem.
Okay, sir.
Thank you.
Okay, sir. Thank you, sir.
Right.
Thank you. Right. Okay. Now here in this slide, I am going to show you the 3 pillars of this 5G technology. The main 3 pillars where this 5G technology is based is first one is extreme data handling capability, and the next one is mission critical, and third one is device density. So what they are, just briefly we will see. First pillar is extreme data. So this 5G technology, it must be capable of handling very high data rates, which I am telling. So 10 gigabits per second peak data rate, and anywhere it should give at least 1 gigabit per second. And in future, the target is even it is beyond 100 gigabits per second. So it must be able to support extreme data rates, right? And next one is mission critical. Mission critical here, it tells something about the latency. As just now I mentioned, it is less than 1 millisecond. This is also very, very important when we go for crucial applications. For example, when we are going for this remote surgery, medical applications, and then when we are going for the self-driving cars, in such cases, even milliseconds delay, it plays a very, very important role. So in such cases, we have to base only on this 5G. And third important pillar is device density. Here I am mentioning almost all 1 million devices per square kilometer area. So really it's a very huge number. if you go to the highly populated cities, really we can have within a square kilometer area like Tokyo, or even in our India like Delhi or Bombay or Calcutta. If you go to the highly populated cities, within a square kilometer area, there will be around 1 million mobiles. And this 5G technology or the 5G network must be capable of supporting all those 1 million devices within that square kilometer area. So these are the three important pillars of this 5G technology. Right. Next, in this presentation, I'm presenting some important achievements by one of the leading companies in the world, Qualcomm. So what they have achieved, you can see in different photographs. In the first photograph, they have developed one handheld device, user equipment with hand blocking capability. These are all based on this 5G technology. And in the second one, we can see seamless handovers using a multiple G nodes. G node means it is the name given to the base station in this 5G technology. They are called base stations in 5G. They are called as G nodes. And in the third photograph, you can see indoor mobility with wall penetration. As 5G uses high data capacity, that wall penetration, dynamic blocking, etc. They have achieved experimentally. This Qualcomm company they have done it. And in the fourth photograph, you can see beam forming. Beam forming and beam tracking is another striking feature of this 5G, which was successfully tested by this Qualcomm company. And next, in the other photograph, you can see in the moving vehicle, which is at a very low speed, how the latency changes and how the handoff changes. Everything they were tested experimentally. So my objective of showing this presentation is presently the most of the research in this 5G technology, it is being done by this Qualcomm research company. Right. Here you can see. You can see the second column and the third column. This we know, this 5G technology we can use at two bands. One is called as a sub 6 gigahertz band, less than 6 gigahertz, and the second one is mm wave. In this presentation, I'm going to show the differences where we can use this sub 6 gigahertz as well as this mm wave technology. So if you go to sub 6 gigahertz, mostly it is used for mobile application. It is based on, of course, 5G is based on MIMO technology only. If you take the number of antennas in sub 6 gigahertz, we can go up to 8 by 8 number of antennas. And of course, presently, even more number of antennas, they were being tested on the user equipments. If you go to mm wave, it is less order. Actually, mm wave, it is of very high frequency, as it is of high power handling capability. More number of antennas, they are not suitable. That's why its capacity is limited to 2 by 2. And tens of users it can cover, this sub 6 gigahertz, whereas mm wave, it can cover a few users with a small coverage area. And coming to the advantage, this sub 6 gigahertz is based on this spatial multiplexing. So the concept spatial multiplexing is one of the important concepts in this MIMO technology, where we can transmit different types of data from different antennas in different channels. Whereas coming to mm wave, the main benefit is it is for beam forming, means through all the antennas, we send the same signal. Its purpose is mainly to improve the signal to noise ratio and to at the same time to attain a beam forming. And coming to the channel characteristics, this sub 6 gigahertz, it works mainly on rich multipath propagation, because that's why I have shown you there 8 number of antennas. So obviously, as number of antennas are more, it has to work in a rich multipath environment only. Whereas coming to mm wave, as it requires a few number of antennas, it is based on it requires less number of propagation paths. And coming to the spectral efficiency, obviously for sub 6 gigahertz, the spectral efficiency will be more because as it uses more number of antennas. And coming to mm wave, compared it is less. Here the point is, we are having sub 6 gigahertz and we are having mm wave. Each is having its own advantage and demerit. And here we have to know where we are using this sub 6 gigahertz and where we are using mmwave. For most of the wireless gadgets, where we can handle comparatively reasonable frequencies, we go for sub 6 gigahertz. And for short distance communication, and for another applications like medical imaging, and for controlling machines, for interconnecting large number of devices, in such cases, we go for mmwave communication. So where humans are not involved mostly directly, in such case we go for mmwave, because mmwave we use the spectrums like 28 gigahertz and 37 gigahertz and 60 gigahertz. They are of very high frequencies, so it is having its own drawback, this mmwave. Right. 5G challenges. There are several challenges in this 5G technology. One of the main challenge and one of the topic of present topic of interest for the present discussion is antenna design. Designing a suitable antenna that can handle this 5G spectrum is really a challenging task, because the antenna must be capable of not only sending and transmitting signals supporting this 5G, at the same time it must be capable of giving beam forming. What is that beam forming? I will show you. That is one of the important design challenge for the antenna in this 5G communications. And next, design of mmwave antennas. mmwave antennas, their fabrication is also a challenging task. And another thing is, as just I mentioned, beam forming. Beam forming means we must be capable of transmitting the antenna's radiation beam towards the desired direction. That is another important parameter required in this 5G technology. It is also a challenging issue. Of course, to some extent, our researchers, they have developed the means, but still there is a large scope for the design and development of these antennas that can handle this 5G technology. Okay, so this is the first part of my presentation. During my second part of presentation, I am going to show you some important and interesting concepts, that is about the scope of research in antennas. Madam, here can I have some 5 minutes break and then we shall start the presentation? Meanwhile,
Okay, sir, no problem. I think the first session we have concluded for this today's session, and then we'll continue after the break, sir. We'll give that break for 10 minutes.
right, sir. So I will
Okay.
come by
So
11:05,
now
sir.
11:05 will start the second session.
Right. So there we can
Right.
continue for 1 more hour, sir.
Yeah, 1 more hour. Okay. Right. Thank you, sir. I request all the participants to take the break for 10 minutes, and we'll rejoin at 11:05 o'clock. Okay. Hello, sir. Are you there? Sir? Hello? Dr. Jagadish Babu, sir, are you there?
Yeah, sir, I am there. Just now I am going to start.
Okay, sir. Shall we continue, sir?
All right, sir. We shall start, sir.
Okay. Right. So welcome back, sir. We can continue the second session of this today. You may proceed now, sir.
Okay, sir. Right.
Right. Thank you.
Right. Welcome back. During the second part of my presentation, I'm going to discuss some of the important areas where we can do some research work. We can go for new PhDs, or we can get some our paper published in some reputed journal. There are like that some important areas I have identified. About each of the area, its characteristic as well as the design challenge I'm going to discuss. Of course, there are many more, but for the sake of brevity and as the time is constrained, some of the important type of antennas here I'm going to present, like MIMO technology, and next dielectric resonator antennas, and then fractal antennas, ultra wideband antennas, metamaterial antennas, next ground penetrating radar antennas, 5G technology, and next wearable antennas, and then RFID, and then finally, just I want to introduce some one of the latest technologies called as characteristic mode analysis, and the combination of some or more of the above technologies. So in these areas, what are the characteristics? What are different types of research problems? We shall see one by one. Right. So first one I am taking here, MIMO antennas. Now I am showing my slide related to MIMO antennas. I think this slide is visible. Sir, is it
No,
visible?
sir.
No.
Yes, sir. Now it's visible.
Okay. Right. MIMO technology. Okay. We know in a traditional means of communication, at the transmitter and receiver, in general, we employ or we keep a single antenna. And using a single antenna, the amount of data capacity that we can achieve is limited according to Shannon's capacity formula. One of the legendary scientists known as Dr. Paul Raj Aragaswamy, and we all should feel proud. He is our Indian. Presently, he is working as a professor in Stanford University. Before that, here in India, he worked as a scientist in DRDO and then as a professor in IIT Delhi. And later on, he moved to Stanford University. There, at the time of sitting in a barber shop, around 1996-95, during that time, he got this idea of MIMO technology. So if we can keep more than one antenna at a transmitter side as well as receiver side, why can't we improve the spectrum efficiency or the data rate? Like that, he got the idea, and that idea slowly he worked on, and he got some interesting results. And even he filed his first patent around 1997. 1997, he got the first patent on this MIMO technology. And he is our Indian Dr. Paul Raj Aragaswamy. Just to see, present technology and all the future technologies, that is 4G, 5G, and even upcoming 6G, they are all based mainly on this MIMO technology. If there is, I am not exaggerating, if there is no MIMO technology, we cannot have this 5G communications. The entire 5G is mainly based on this MIMO concept, right? What is MIMO? So in MIMO, just as I mentioned, as we are employing some multiple number of antennas and antennas, a transmitter and receiver, we can enhance the data speed by n number of times. It was proved mathematically, where n is the number of antennas. So n number of times the channel speed can be, the data speed can be enhanced. In this MIMO technology, there are several challenging problems are there. The challenging problems are related to transmitter design, the problems related to receiver design, and the problems related to channel. And then the important concept, the problems related to antenna design, which is the topic of present discussion. Antenna design is one of the main challenges in implementing this MIMO technology. The reason is, as we are telling, in MIMO, we have to employ multiple number of antennas in a given location. As you are employing multiple number of antennas in the given location, in the given device or given location, as they are keeping nearer, there arises a problem called as mutual coupling. Because of this mutual coupling, the radiation coming from one antenna, it interferes with the radiation from the other antenna. So because of that, the signal will be lost. The data is deteriorated. This is one of the main problems in this MIMO technology. And how we can overcome this mutual coupling? One of the crude method of reducing this mutual coupling is to maintain some optimum distance between the antenna elements. But if the distance between antenna elements you are increasing, obviously the device size will be more. So it is the drawback. So there is a trade-off between the device size as well as the distance you can keep between the antennas as well as the mutual coupling. It is one of the really challenging problems, and where so many of our researchers presently they are contributing. And even interestingly, one of our colleague friends, Dr. Tatababu sir and Dr. Koteswara sir, and some of our peers also, they are working in this MIMO technology, and the problem taking this problem of enhancing isolation between the antennas. So in the slide, I am presenting some of the MIMO antennas. So in the first photograph, there you can see a swastika shaped antenna. It's a MIMO antenna because there are two similar antennas are there. This was the antenna, of course, I have developed as part of my PhD program around 2012. 2012 it was developed, and of course it was published in one of the SCA journal, Microwave and Optical Technology Letters. It's one of the examples. Like that, you can take various random shapes, and the end objective of all taking various shapes is reduction of mutual coupling between the antennas. And next, the size of the antenna must be as small as possible. These are the main objectives. And of course, in the second photograph, you can see one of the wireless gadget router, where it has employed a multiple number of antennas. There are 3 antennas are there. It is purely based on this MIMO concept. 3 antennas, they are transmitting data, and the objective is so that the speed can be more. And in the third group photograph also, you can see there are a different number of antennas. So each feed corresponding to the insertion of an antenna. Like that, on a common platform, how different number of antennas are integrated, we can see in this third photograph. Right. Design challenges in this MIMO technology. As I am telling, the first design challenge in this MIMO technology is having good amount of isolation between the antennas. In the olden days, when we have taken traditional antenna arrays, we know the optimum distance between 2 antennas is taken as lambda by 2. But coming to this MIMO technology, we cannot design antennas with lambda by 2 spacing, because if you take lambda by 2 spacing, the size of the device becomes very more. So the size must be the spacing must be less than lambda by 2. So there are plenty number of antennas they have been developed, and they are published in research journals with the spacing between the antennas as some 0.1 lambda, 0.2 lambda, like that. So having that minimum separation is important. But while going for that minimum separation, there comes the problem called as mutual coupling. So this mutual coupling should be as low as possible. Really, this is a challenging problem. Separation must be small, as well as mutual coupling also must be very small. This is one of the main problem. And the second point here you can see size reduction. So this mutual coupling reduction and size reduction both are how they are related. Just now I explained. And another important challenging problem in this MIMO technology is design of MIMO antennas that can be operated for ultra wideband operation. Of course, here why I am telling this as a design challenge, I would like to tell. Ultra wideband, we know it is from 3.1 to 10.6 gigahertz. It's a huge bandwidth. In this bandwidth, we can develop some MIMO antenna which can operate from 3.1 to 10.6. But here the real design challenge is designing the antenna giving stable radiation pattern throughout the band is a challenging problem. In 2017, when I attended some international conference in Singapore, I have presented some MIMO antenna covering some ultra wideband spectrum. So after my presentation, one of the professors from that university, there he asked me, so your entire presentation is okay, fine, and your design also looks good, but there is a main drawback in your design. Can you can you tell the drawback like that? I was asked. Of course, by the time I was not able to answer, but the answer I got that from that professor is, your so-called developed antenna is giving good amount of isolation. Okay, its size is also small. Okay, but your antenna is not suitable for practical application. The reason is it is not able to give stable radiation pattern beyond 5 gigahertz. After as the frequency is getting increased, the pattern started getting distorted. Here I would like to tell one thing. Most of the researchers, of course, they are designing some MIMO antennas. They are able to achieve good amount of isolation, and they are able to get some size reduction, etc. But they are not focusing on this stability of radiation pattern. So as they are not focusing, so we can say that it is one of the challenging problem, where if we can take up that challenge and we can design some good MIMO antenna where we can get some stable radiation pattern, definitely that work can be published in some reputed international journal. So these are some challenges in this MIMO technology. Right. Next, I am stepping into second category of the antennas, which is called as dielectric resonator antenna. Okay, here it is a special type of antenna. There is a difference between the traditional microstrip antenna as well as this dielectric resonator antenna. In a traditional microstrip antenna, we know the main radiating element is the conducting patch. As I have shown in the swastik shape, actually the swastik shape, it is a conducting patch. Using the conducting patch, when it is attached on the substrate, they develop some fringing fields, and those fringing fields will be radiated into space in the form of some electromagnetic radiation, which we are calling as a signal in communication technology, etc. Coming to DRA antennas, here, instead of going for this conducting patch, we take dielectric material. Really, it's an interesting thing. Here, there is, except feed, there is no conductor involved. Rather, we take some dielectric material which can radiate fields into the space. So in the second photograph, there I am showing you some of the pieces of this dielectric antennas. Now, as we are having this traditional microstrip antenna, then what is the need of going for this dielectric resonator antenna? Some brief points here there I mentioned. These dielectric radiator antennas, they give high amount of radiation efficiency. That is a main advantage. What is the reason? The reason is here there is no conducting element involved in the radiation. because efficiency, it mainly depends upon the conducting losses of the antenna. If there are more conducting losses, obviously its antenna efficiency will be reduced. As in dielectric resonator antennas, as there is no conductor involved in the radiation except that feed, obviously here we are going to get a high amount of radiation. This is one of the main advantages why these DRA antennas they were developed. And next, another striking advantage of this DRA antenna is they occupy small volume, because we know the size of the antenna and the dielectric constant, they are inversely proportional. So larger the dielectric constant value we are taking, smaller the volume size we can get. Usually in these DRA antennas, that radiating element dielectric constant value is taken very high, around some 9, 10, 20, 27, like that high values we used to take. Because of those high values, obviously they occupy small volume compared to the microstrip antenna. And next, they can handle large powers. This is another advantage of this DRA antenna. As it is the main radiating element is the dielectric element, and as it is not a conductor, obviously they can handle large amount of power. And next, they give high gain. As they are having high gain and they can handle large powers, automatically these antennas, they are more suitable for MWave frequencies. So these are some of the features of this DRA antennas. Okay. Here in this presentation, I am going to show some of the DRA antennas that were developed by my research scholar. Of course, they were published in some reputed journals like RF CAD and Microwave Technologies. Here, we can see the first diagram. I'm showing the top view of this dielectric antenna. There you can see it is a CDRA, means a cylindrical dielectric resonator antenna. And beneath that cylindrical dielectric resonator antenna, you can see some feed is attached. That feed diagram you can see in the third photograph. The SMA connectors and how the feed is given there, you can observe in this third photograph. So upon that feed, this cylindrical DRA is attached. And next, in the second photograph, there you can see the bottom view of this proposed antenna. There, of course, we have taken some slots. By taking that, we are getting our desired bandwidth and some desired properties we have obtained. This is one type of DRA antenna. And next, I am showing another type of DRA antenna. Here you can see this is of course, these DRA antennas, just like our microstrip antenna, we can design them in variety of shapes, and each shape is having its own unique property. So these shapes we can go randomly based on our requirement. The requirement can be like radiation pattern improvement, or it can be isolation improvement, or it can be desired polarization, or it can be device size restriction, etc. Based on the requirement, we can go for different variety of shapes of these dielectric elements. Here in the present figure, what I'm going to show you is, it is called as asteroid shaped DRA. It is a MIMO antenna. So there are two asteroid shaped dielectric antennas where they were taken, and their feed element it is given in the third photograph. You can see feed structure. So it is a structure. It's like half semicircular angular structure. Upon this structure, this asteroid shaped DRA, it is being attached. Like that, both the antennas are developed. And here in the figure 4, we can see the ground plane. And the ground plane is also designed in a different ways. Variety of ways it can be designed, and based on our requirement, like desired operating frequency or desired amount of isolation, we can go for a variety of shapes. It is one of the shape it was taken. So similarly, some other examples I will show you. These DRAs, they can be of variety of shapes, like L shape, and the second figure we can see this is U shape, and next we can see Z shape. Like that, variety of DR antennas they can be developed. Okay. Now let us see what are the design challenges in these dielectric resonator antennas. One of the main design challenge in this DRA is feeding. Here, by taking a simple cylindrical DRA, and if you can design the feed in a novel way, you can get that paper published in some reputed SCA journal. So in DRA antennas, designing of feed in a novel way is also one of the challenging tasks. It is one of the challenging problem which we can handle. And next, performance in MIMO environment. Means you can develop some novel DRA antenna that can work well in MIMO environment. So working in MIMO environment means in my previous slides I have given. So any antenna, it can work properly in MIMO environment if it can give lesser amount of mutual coupling, if the device size is small, as well as if it can give stable amount of radiation pattern throughout the band. If we can use such features, we can say that that antenna can work well in MIMO environment. And next, another challenge is mode analysis. This mode analysis is really one of the challenging problems in DRE antennas. Even they are very difficult to understand also, this study of modes. If you take a microstrip antenna, the usual modes, we know they are TM mode, TE mode, like that, normal modes we get. But if you go to DRE antennas, we get some hybrid modes. And understanding those hybrid modes with the help of these electric fields is somewhat difficult. But really, if we can understand how those fields are coming and how they are related to different types of modes, if we can get the complete concept, then definitely we can get that work published in some very good journal. It's really a challenging task understanding those modes also. And recently we have seen some papers related to DRE antennas and applied to 5G communications. So in 5G communications, we are having number of variety of antennas we can use, and DRE also is one of the antenna that can be conveniently used for this 5G communication. Because 5G power handling capability is also one of the tasks. As just I mentioned, these DREs can handle large amount of powers. So definitely these 5G antennas are one of the suitable choices in 5G technology. And another thing is design for ultra wideband applications. So like this, we are having a different design challenges related to DRE antennas. Next, ultra wideband antennas. Of course, here I am presenting some of the UWB antennas. Here, UWB frequency range is as defined by FCC. The frequency range is 3.1 to 10.6 gigahertz, and their main purpose is they can be used for a short distance communication to achieve secure communication and to give high data rates, etc. And designing ultra wideband antennas is very easy by modifying the ground structure and by keeping some stubs, and easily we can get ultra wideband operation. But designing ultra wideband antenna with, again, as I said earlier, stable radiation pattern is again a challenging task. Here I would like to show in the next slide. These are some of the practically developed ultra wideband antennas. They were published in some journals like Talleyrand, Francis, etc. So this ultra wideband operation, it was achieved by reducing the ground plane. Of course, obviously for the beginners, I give some suggestions. If you want to improve the bandwidth, you just cut off the ground plane. If you cut off the ground plane to some extent, or if you can play with the ground plane, by playing with the ground plane, you can get different resonances, and those resonances can be mixed so that you can get ultra wide bandwidth. This is one of the easiest way of getting this ultra wideband operation. Right. Design challenges. First point is stable radiation pattern. In the literature currently, there were number of papers are published on this ultra wideband technology. Ultra wideband antennas using MIMO technology. Next, ultra wideband antennas with the band notch properties, which I have given in the second point. Band notch properties. So we know the ultra wideband spectrum, it is from 3.1 to 10.6 gigahertz. But in between 3.1 to 10.6, there are a few bands which are we are having, like Wi-Fi, WiMAX band, and next wireless LAN band, which is from 5.15 to 5.825. Like that, we are having different bands are there. So this ultra wideband spectrum may interfere with those wireless LAN bands or WiMAX bands. Definitely, it may cause some nuisance. It is some problem. So if you can design some antenna which can notch or which can filter those spectrums of WLAN or WiMAX or Wi-Fi, whatever it may be, etc., then definitely you are able to design a new type of antenna, and that one you can publish in some reputed journal. It is one of the problems. Already a number of papers are published. Still, there is a large scope to get our work published in this specific area, design of ultra wideband with some band notch characteristics. And the third point is high bore sight gain. This is the problem where thus far, less focus is given. So far, mainly ultra wideband antennas, they were published in the areas like MIMO areas, that is a reduction of mutual coupling or reduction of area, or with the band notch properties. There is a third area where we can focus, that is giving higher amount of bore sight gain with a stable radiation pattern. So if you can design some antenna which can give undisturbed pattern throughout the entire band 3.1 to 10.6, as well as giving higher amount of bore sight gain. So bore sight gain means the amount of the maximum power delivered towards 0 degrees, we can say. It is called as bore sight gain. So like that, if you can get that antenna, definitely it becomes a good work. And another challenging problem that can be taken up in these ultra wideband antennas is time domain response. It is also given so far some least importance, but of course there are some papers. Still, this is the area there are more chances to be explored in this specific concept, time domain response. The reason is, in this ultra wideband developments, we have to transmit some short amount of pulses. So understanding the time domain response of those short pulses is also one of the problems we can handle, and we can design the novel antennas, how they can deliver these short pulses and how can be transmitted like that. If you can make some analysis, then definitely it becomes a very good work. So like this, we are having UWB antennas. Next. Right. Now we can say meta material antennas. I can say this as a king of antennas nowadays. Why I'm telling you king of antennas is, if you can see some repeated journals like presently I can say IEEE transactions on antennas or any reputed journal, if you take, more than 20 to 30% of the papers that are getting published in one way or other way, they are based on this meta material technology. Right. What are these meta materials? Here in the diagram you can see these meta materials. They are broadly classified into 4 categories. Just briefly I will tell what they are. So meta material means they are man-made. They are not naturally available. In the nature, there are some materials which are available naturally. So if it is not available in nature, then we call it as a meta material, and different classifications we can see. So first category of material is DPS, means double positive. So in the figure, if you observe, here epsilon is greater than 0 and mu is also greater than 0. So such materials, in such materials, if you use for antennas, here the wave can be propagated in the forward direction. It is called as a DPS. And next there is another category, ENG, means epsilon negative. So here this is epsilon value, it is negative, and whereas mu value is positive. So for example, it occurs in the plasma materials. So in such cases, what happens is the wave will not propagate in forward direction. It's called as evanescent propagation. The meaning of evanescent propagation is the electromagnetic energy is struck in that material and it oscillates. It oscillates forth and back, front and back. It oscillates and it will not propagate. So if the value of epsilon is less than 0, this is another category. And next, third category, it is called as a double negative, DNG, where epsilon negative and mu both are negative. So if both are negative, in such cases, wave, it propagates backward direction. This is another category of this metamaterial. And next, there is a fourth category. It is called as a mu negative. So mu negative means here epsilon value is positive, but mu value is taken negative. So it occurs in the materials called as ferrites. Here also the propagation is evanescent propagation. So you can see in second quadrant as well as fourth quadrant, simply the wave will not propagate forward or backward. Simply it oscillates. So based on the applications, we can fabricate the material and we can use for our own purpose. And how it is, again, it is a topic of a long discussion. So in brief, here I presented. Further, if you want, you can explore. Here, what I'm telling is, nowadays, there are plenty of research papers are being given importance in the development of metamaterial antennas. And the examples of some cases I'm giving, like FS, says frequency selective surface, and next artificial magnetic conductor, and then high impedance surface, etc. These are some examples of this metamaterial. One example here I would like to show how this one of the metamaterial category, which is called as artificial magnetic conductor, how it works. Just I would like to show you using this diagram. So are you able to see this slide, artificial magnetic conductor? Hello, any of the audience, please. Are you able to see
No,
this
sir.
slide?
No, sir. Still we are in metamaterial antenna slide.
Right. Now are you able to see?
Yes, sir. Yes, sir.
Right. Okay.
Yes, sir.
Right. Okay. Okay. Here, let us see this first diagram. Here, this is the one of the antenna. It is transmitting signal in this forward direction. It is, I'm calling it as a direct wave, like this. Next, behind this antenna, at some space, I'm keeping some PEC. It's a perfect electric conductor. So this backward radiated signal, when it comes back and it is getting reflected, we know it takes a phase shift of 180 degrees, opposite phase. So it also comes now in the forward direction. So this direct wave and the reflected wave, now they are having the opposite phase. Because of that, the signal propagating in this opposite direction will be attenuated. It will be distorted when we are taking some perfect electric conductor. Okay. Now you take the second figure. Second figure also same, but the difference is, in place of this perfect electric conductor, now I have taken some AMC, artificial magnetic conductor. And the important property of this artificial magnetic conductor is, when the signal from this antenna, so this is the antenna, it is coming backward and it is getting reflected. There is no phase shift. It is the important property of this artificial magnetic conductor. There is no phase shift now. So now it is coming forward. Now direct wave and reflected wave, both now they are having the same phase. Now as the direct wave, reflected wave, as both are having same phase, they will be reinforced each other, means they will be added each other. Because of that, we can get a high amount of directivity. So whenever you want to get a high directional radiation beams, high amount of directivity, in such case, we can go for this AMC structure, means artificial magnetic conductor. So here I have shown you one of the developed artificial magnetic conducting structure by our team. So you can see here. So above this artificial magnetic conductor, you can keep some antenna. So if you keep some antenna, then obviously the antenna's direct radiation and the reflected radiation both will be added each other. so that we can get a high amount of bore site gain and a stable radiation pattern as well as a high amount of directivity. So in such case, we can go for this AMC structure. So just here, I have shown you only one example of how we can take the metamaterial and you can use it for your purpose. Not only this one, there are so many applications where we can use. You can see here, if you want to get high amount of gain, or if you want to enhance the impedance bandwidth, or even for the size reduction, or stable radiation pattern, just I discussed it. And even in the reduction of coupling, which is the main problems in the MIMO systems, for any of the cases, you can go for these metamaterial antennas. So there is once again I'm telling for the beginners in antennas who want to pursue their PhD or who want to get their research work published. This is one of the hottest areas nowadays. Right. Okay. Next type of antenna, it is GPR antenna. It's called as GPR, means it's called as ground penetrating radar. First of all, I will tell you practically where these GPR antennas are used. These GPR antennas, they are used especially to track some landmines. So whenever our police are combing in Naxals areas, the important thing is they have to carefully check whether there are landmines or not. So in such case, the type of device we are using is this GPR antenna. And in the ground, to study the soil properties, in that case, we have to use GPR antenna. And similarly, in archaeology, in civil services also, inside of the walls, the strength of the wall, without breaking anything, the strength of the wall, everything we can study with the help of this GPR antenna. It is also one of the thrust areas. You can see here it is one of the antenna developed from IIT Kharagpur. So it's one of the GPR antenna. Its size is large. It's around some 30 centimeters. The type of antenna I'm showing is a bow tie antenna. This is the antenna which we have developed there. So the main important property of the GPR antenna is it has to give good amount of radiation towards the bore side direction. That is one of the important property. Bandwidth, no problem. If it is lesser, no problem. And if you are going for a MIMO, coupling is higher, no problem. But the main thing is it has to give higher amount of bore side gain. Why I'm telling is, for example, imagine using that landmine, GPR device, we have to search for that landmine. Means when you are keeping the device just above the surface of Earth, the radiation coming from that GPR device should go vertically downwards. Vertically downwards, it should penetrate the Earth and it has to detect. Means the radiation should be vertically only. Means we are saying that there the bore side gain is very high. Suppose if the radiation coming from the device is not going vertically, it is tilting some other direction. So what will happen? So it goes to other area other than this landmine, then the result is a destruction. So it's a very huge problem. So the main important point is, if you want to design some GPR antenna, the bore side gain should be as high as possible. So here I am showing you some design challenges. You can see stable radiation pattern. Of course, device size, though it is not the main criteria, it is also one of the design challenges. And a stable radiation pattern and high bore side gain. This is the important property when we are going for this GPR antenna. Super wide band. Why I'm telling super wide band is these GPR antennas, another design problem is they must be designed at low frequency of operation. This is another design challenge in this GPR antenna. Because why I'm telling low frequencies, most of the GPR antennas, they work at say some 1 gigahertz or 2 gigahertz only. We cannot go for high frequencies, say 5 gigahertz, 7 gigahertz, 10 gigahertz, we cannot go. The reason is as the frequency increases, signal frequency increases, And in GPR application, the signal has to penetrate into earth, which is a good conductor. If the frequency is becoming more, obviously the signal loss will be more because it depends on the frequency from skin effect. So we cannot go for very high frequency signals. It should be operated at low frequency only. This is another important design challenge. And then low ringing. This is another broad concept, ringing concept in GPR antennas. Here, I would like to tell that this is one of the area where presently some least importance is given. Means in the literature, if you find only few papers are available in this particular area of GPR antennas. So if you can take up the challenge in this area, definitely we can easily go with a paper. There are so many design problems are there, like getting super wideband and going for low frequency, and then having a high bore rate gain and having a stable radiation pattern. Stable radiation pattern is another very, very important required characteristic for this GPR antenna. Stable radiation pattern and high bore rate gain. Miniaturization, of course, it is required, but still it is not a problem. The reason is, you might have seen the landmine detection devices. There, the size is not a big problem. Right. Next, we are going for another category of antennas, fractal antennas. Fractal. Fractal means self-repetitive or self-similarity. This is also one of the areas where comparatively less number of papers are available now. But the design is very interesting. Once you go with fractal antennas, definitely we can go for some good journals. Initially, these fractal antennas, they were developed by Nathan around 1988. The details and the types of different antennas developed by Nathan and their team, even now they are available. The website I'm giving, if you are interested, you can see, that is fractana.com. There you can find them. These fractal antennas, we can use mainly for broadband operation as well as for multi-band frequency. In the figure there, I am showing you what is the meaning of this fractal. For example, you see, first in the 0th iteration, I have taken a triangle shape. This is a single triangle shape. In the next iteration, you see, again I have formed a triangle shape, and there the basic element is this first taken triangle. So it's called a self-similarity. Next, you see the next iteration. In the next iteration, here I am getting again same triangle shape. Here also the entire triangle shape is formed with the help of the first taken element. So it is one of the properties of this fractal antennas. So ideally, this is not the case. Most of the fractal antennas are based on this property. Some of the fabricated fractal antennas here I am showing. You can see it's in the form of tree. Some other random shapes you can observe here. Right. So design challenges. If you see the design challenges, there is a good scope for designing novel shapes, giving reduced size and enhanced bandwidth. And interestingly, there are some papers available with fractal antennas combined with metamaterials, which I have shown earlier. These are the metamaterial antennas. So these metamaterial antennas, if you combine with this fractal concept, it becomes a novel concept, and you can go for a good paper. Right. Next, another category is wearable antennas. Wearable. So nowadays, so no need to tell. We are using smartwatches, and next we are having a Google Glass, etc. Where the smartwatch or Google Glass, they are integrated with Bluetooth as well as Wi-Fi antennas based on the requirement. So these wearable antennas are having their unique importance and unique applications. And design of these wearable antennas, really it is a challenging task. The reason is, as these wearable antennas, they are attached near to the human body. When you are designing that wearable antenna, there are some specific criteria we have to meet, like SAR, SAR of that antenna, specific absorption rate, one of the important point. And next, that antenna should give high radiation efficiency. Why I'm telling high radiation efficiency is, as this antenna we are wearing near to the human body, as the human body is a good conductor, some of the energy will be lost. As it propagates into our human body, some of the energy will be lost. So obviously antenna's efficiency will be reduced. So it is one of the challenging tasks when we are going for this wearable antenna. Right here, I am showing another example of this wearable antenna, how they are very helpful, highly helpful in defense applications. See here, you can see it is one of the antennas developed by some Russian military. See, this is the antenna. This is one of the body wearable antenna attached to the body, and with the help of this antenna, this soldier is able to communicate with his peer soldier. Even he can send video signals. So about his location and about his information, everything he can share with peer group members. So this is the camera here. It is put. This is a camera, and that video signal, it can be sent with the help of the antenna. This is the antenna which is attached to the body of this specific soldier. This is another example of wearable antenna. Mostly wearable means we know about Google Glass or smartwatch, but in defense, these antennas, they play a very, very important role, very key role. Frankly, to say, this is also one of the area where only very few number of papers were published in wearable antennas. Still, the research is in the infant stage, we can say. We can see the design challenges like miniaturization. The device size must be small, because earlier I have shown the soldier diagram. There, if the size of the antenna is heavy and bulky, it becomes a burden to the soldier. Apart from his regular luggage, if the size of the antenna also becomes bulky, it's a drawback. So miniaturization is one of the important features in these wearable antennas. Next, as I mentioned, antenna efficiency. This is also another point. Most of the cases when we are going for these MIMO antennas or ultra wideband antennas, or even metamaterial, most of the papers, you do not find anything about mostly antenna efficiency. The plots will not be given. But if you are going for wearable antenna, there definitely you have to mention what is your antenna efficiency. Based on your antenna efficiency only, you can claim that your research work it can be used practically or not. And like there are some antennas that can be developed for GPS, etc. Okay. Right, RFID antennas. So we know radio frequency identification tags. It is one of the categories of antennas. In the real time, it is one of the categories where we have seen many times RFID tags. In this diagram, a brief view of this RFID system we can see. First, it is called as inventory computer, which can control RFID readers, where each RFID reader it can control multiple number of antennas. This is the antenna. So this is the antenna which can transmit or receive the signal. And here, this is the actual RFID antenna. This is the antenna where this antenna is attached to multiple tags. So these are all objects. Suppose if you are going to the supermarket, to the multiple objects, these tags can be inserted, and so that they can be transmitting information, and that can be received, and that received information it is processed by the RFID reader, and then it will be sent to the inventory computer. So presently we are having different types of these RFID antennas. And coming to the research problems in these RFID antennas, so these are the problems. Miniaturization. And another point is having circular polarization. Circular polarization is the most desired characteristic or feature for this RFID antenna. Why it is so, I will tell you. There are, you all might be knowing, these RFID antennas we can use for some specific application like tracking animals in the forest. like lions or tigers, we can track them. Recently, you might have seen a newspaper. Some of the lions, how many kilometers they have moved around the jungle over a period of 1 year or 2 years. Everything our scientists, they are capable of tracking. And even some of the recently we have seen they have attached some RFID tag to a bird, and in a span of 1 year, how many kilometers that the bird has flown, they have calculated, and they wondered almost 1 lakh kilometers that bird has flied within a span of 1 year. Exact location, everything, our scientists were capable of locating it, and that was possible only with the help of this RFID antenna. Here, this RFID antenna, for example, imagine this is attached to some tiger or lion, and it is roaming around the forest. Means our RFID reader, it has to track the signal from any location, from any direction. Whenever you are going to track the signal from any location or any direction, there, the important property, required property of the antenna is circular polarization. So why it is so, I am not going for the basics, but we all know circular polarization, it can receive both horizontal polarized as well as vertical polarized without any loss. So it is one of the properties, circular polarization. And next, there are other design challenges like good impedance matching, and even they must be suitable for wearable communication, like that. Right. Another interesting area I'm going to touch, that is antennas for biomedical applications. Right. Right. Here I am showing one of the antennas developed by our team. We are doing some research project in collaboration with Saudi Arabia University. So there we have published some papers also. It is about glucose sensor antennas. Antennas that were developed for detecting glucose concentration in blood samples. Actually, in a human body, how we can detect sugar levels, we know. How we can detect? We are having a finger pricking method. So the needle is to be pricked into the finger. We get some blood, and that blood is tested. Like that, we have to detect the glucose levels in our human body. So definitely it is having its drawback. Every time it causes pain, there are so many problems. Recently, our researchers, they started working on developing microwave sensors. Microwave sensors and antennas that can be used to detect the signal. So it's a topic of broad area. It's an interesting topic. And here also I'm telling, in this area also, there are few papers published, but getting a paper published in this area is a little bit difficult, because it is related to biomedical. Definitely the reviewers, they will see the accuracy of your measurements. If the fabricated antenna is not capable of giving accurate results for real time, it is of no practical use. So such cases, the paper, it is difficult to get accepted. So it is one of the such antenna we have developed recently, and it was published in some journal, Science and Engineering of Composite Materials. Here on the bottom, I am showing the finger phantom. This is called as a finger phantom. Phantom means not real. So instead of finger in the simulation environment, we have to design this phantom. And by keeping this phantom over this antenna, we study different amounts of frequency shifts. And those frequency shifts will give the information related to the amount of glucose concentration. And coming to this, we are having a different design challenges, like miniaturization. Size is very, very important. Next, high frequency shifts, because as I was telling, based on the frequency shift only, here we can detect the amount of glucose concentration. So if you can get a good amount of frequency shift in the range of megahertz for each variation of glucose, say if the glucose is changing from 100 mg per dl to say 200 mg per dl. So from 100 mg per dl to 200 mg per dl, if you are able to get a frequency shift of say some 5 megahertz or 10 megahertz, then obviously we can say it is a good sensor, and getting a high amount of sensitivity. High amount of sensitivity is also one of the design challenges. And next, wearability. As I'm telling, it is for biomedical, wearability is always a design challenge. Right. And another important thing I would like to present here is breast cancer detection. It is also one of the applications detecting tumors in the human breast. So there I will show you the design challenges. In the breast cancer detection, so that sensor must be of compact size, and it must give enhanced bandwidth. High bandwidth is also important, and higher efficiency. Once again, I'm telling here higher efficiency, because this is attached to the human breast to the our breast phantom. As it is a human body and as it is a good conductor, certain amount of radiation is lost. Okay, so in such cases, the antenna efficiency may be reduced. So your developed antenna sensor must be capable of delivering high amount of efficiency. It is one of the design challenge. And whenever the antennas are attached to the breast phantom, because of the inside breast material, some of the signals will be unwanted reflected signals will be there. So handling those unwanted reflected signals, all these things are different design challenges in this specific area. And next, to good radiation characteristics, and designing this sensor of low cost, it is another area of challenge. Right. Now I am moving on to the topic of present today's discussion: 5G antenna design and challenges. Right. Okay, you can see in the 5G antenna, the main design challenge is beam forming. See, this is GNB. GNB means the base station in 5G technology. We can call it as GNB. So this base station, it must be capable of supporting n number of users.
Hello,
Okay.
sir.
Sir.
Sir, your slide is not moved.
Right, sir. Now the slide is 5G antenna design challenge.
Now okay, sir. Right.
Okay, sir.
Thank you, sir.
Right. So one of the important features, as I mentioned in 5G, is individual support to each user must be there from the base station. So here the signal must be of narrow beam, and it has to support multiple number of users. So multiple beams are to be delivered. In the second figure, you can understand how. So there are, I have taken two base stations. This is one base station and this is the second base station. So how they are delivering individual radiation beams to the individual users, we can see. So here the beam must be as narrow as possible, and it must be capable of switching from one position to another position, or from one user to other user. That is one of the design challenges when you are going for the 5G antenna. So again, in the next slide, I will show you what is that. Right. So here you can see what is beam forming. You will clearly understand with the help of this slide. Just to look at the first diagram. In the first diagram here, I have taken one radiating element. So this is the radiation beam. The radiation beam is wider beam you are getting. In the second diagram, I am taking two radiating elements. So as there are two radiating elements, if you observe compared to the first lobe, first figure, in the second figure, the radiation beam is somewhat narrower. Of course, with the occurrence of some side lobe. Okay. Now you go to the third figure. In the third figure, we have taken four radiating elements. 1, 2, 3, 4. Four elements we have taken. You just see how we are getting a narrow beam. Getting a narrow beam, narrow and sharp beam is very much required when you are going for this 5G antenna technology. And this one you are getting with by taking 4 number of antennas. Now you can clearly understand why we were telling MIMO is the heart for this 5G technology. If you take a single antenna, you are getting this radiation pattern. Whereas if you're taking 4 number of antennas, you are getting a sharp beam like this. A sharp beam which is very much required in this 5G communication. Again, in the next slide also, I will show you this one. So here also you will understand. Suppose there are 4 antennas. This is the beam we are getting. Here, this beam, this one we can change its position from one direction to other direction with the help of the phase shift from antenna to the antenna. As there are 4 antennas, as you are giving some source signal, by changing that phase information, you can change its location from user 1 from here to another location. Like that, you can control the radiation beam. It's called as suppose, for example, here they're telling if you give 45 degrees of phase shift, it can be rotated towards some specific angle, like that. Same way, if you are taking the second figure, the radiation beam, how it can be switched from one user to other user. This is user 1, this is user 2. Same way here also, by controlling the amount of phase shift between the individual antennas, you can control the beam from one user to the other user. Simply, this is the concept of beam steering and beam switching. This is also one of the important properties which we have to consider when we are designing and developing 5G antennas. Right. I am showing one example of a device in the MIMO environment like this. So multiple number of antennas when you are keeping, we have to keep the device size must be as small as possible. Here I have mentioned some challenges. Need to improve the isolation between antennas. This is one of the important challenge when you are designing this 5G, and the need of developing compact antennas. So size must be small as well as isolation also must be very high. Mutual coupling must be very small. Right. Actually, antenna designing means so far we are focusing only on the antenna which is attached in the device. And most of the research papers also, they are published on the antenna design which are connected to the device, that is your mobile phone. But there is another area where we can design the 5G antenna that can be suitably integrated into the G node, that is the base station. Like this, you can see base station is also very important because from user to user, how the signals they are propagating with the help of base station only. So the base station supporting these 5G signals and the antennas, design of these antennas is also one of the challenging tasks. Unfortunately, this is the area which is, where our researchers they have paid some less attention, and there are only few research papers that are published in this specific area, where the design and development of base station antennas for 5G communication. Of course, these are the problems related to communications, not antennas, considering channel estimation in this 5G communication, and next considering path loss due to atmospheric absorption, because as we are discussing 5G, it is for high frequency. Because of high frequency, whenever the frequency increases, the absorption from atmosphere will be more, because more the frequency, more the loss, more the absorption. That's why at the time of rainfalling also, exactly we cannot get our dish TV or even mobile phone signal. The reason is because of that rain drops. When the electromagnetic wave propagates, the signal strength is fallen. It is attenuated. It is one of the challenges which we have to study in this 5G communication. Okay. I will show one just a simple example, and then we will wind up this discussion. How to design some 5G antenna. These figures I have taken from REMCOM simulator. So courtesy is given to REMCOM. These are copied pictures, but these slides I am showing you how the radiation pattern of 5G antenna, it switches from one location to other location. So there in the figure you can see how multiple antennas are taken, and in the second figure, this is a radiation beam. There are 4 antennas. 4 antennas are there, rectangular patches. This is the antenna which can be operated 6 GHz frequency. Okay, so this is second figure. It is a radiation pattern. Okay. Now look here. This is the antenna which is intended for virtual reality application. So by changing the phase shift between antenna to antenna to an amount of 90 degrees. See here, 90 degrees. Then I can beamform, or I can change the position of this radiation pattern for 30 degrees. So the phase shift between the individual elements is important to control the beam forming capacity of this antenna. So this is the antenna which is practically used for virtual reality applications. Right. Of course, this is one of the areas, thrust areas, where recently some good number of papers are being published. This is a characteristic mode analysis. It is an area of broad scope. So just in brief, I would like to tell. This is the latest area, and my advice to the beginners who want to do their PhD work, or who want to get their research paper published in some good journal. Suppose they have developed some antenna. That antenna, if they can reinforce that concept to this concept of CMA, which is called as a characteristic mode analysis, then the chances of getting your work accepted is high, because it is one of the latest areas. So here I cannot discuss because of time constraint in detail about this concept, but just you can note down this area. It's called as a characteristic mode analysis. And these are some research works which are published in some IEEE transactions like that, based on this CMA, characteristic mode analysis. And in this slide, you can see what are the different design challenges we can cope up with the help of this CMA technology. Suppose you have developed some antenna and you want to enhance the bandwidth, then you can go for CMA. And you have developed some MIMO system, and you have to reduce the mutual coupling in a more systematic way. You want to develop, then you can go for the CMA. And similarly, you want to analyze the meta surfaces, which is have shown in the previous figure. Suppose you see this figure here, it is a meta surface antenna. They're called meta surface. So applying a CMA to meta surface is also one of the thrust areas. So how radiation patterns are coming, how null is there, how high bore set is there, everything we can see here. Next, to control radiation pattern, it is another important challenging aspect of this CMA. So these are all different areas where we can study with the help of this latest concept, which is called as CMA, characteristic mode analysis. Right. Thank you. This is all what I want to present in my 2 hours of presentation. And thanks for the opportunity once again to the management of Aditya Group of Colleges, the principal sir, HOD madam, and especially to my colleague friend, the coordinator of this FDP, Dr. A. Tatababu sir, and to all the participants for their patient listening. Thank you. Thank you very much.
Thank you, sir. Right. Thank you, sir, for such an informative session on antennas applications in wireless communication research perspective, which covered the various topics like basics or traditional means of communications and evolution of 5G, MIMO at sub-6 GHz and millimeter wave, challenges in 5G communication during the first session of this first part of this session. And in the second part, you have covered the current trends and the scope of research in antennas, like constructional properties, design challenges, and applications of various antennas like MIMO, dielectric resonator antennas, UWB metamaterial, artificial magnetic conductor, GPR, fractal, wearable RFID, and glucose sensor antennas for biomedical applications. Finally, the 5G antenna design and challenges and introduction to the characteristic mode analysis. Hope these topics will be significantly useful for the young scholars to take up their research and where exactly they can focus on the field of antennas. And hope these participants can be enjoyed this session by gaining enough information on antenna design and challenges. Now, I request Professor Dr. G. Sridevi Madam to start the closing ceremony. Thank you, Madam.
Thank you, sir. Ladies and gentlemen, good afternoon, respected guests, distinguished faculty, and esteemed participants. I'm Dr. G. Sridevi, coordinator of this FDP, with immense pleasure and honor today as we conclude this remarkable one-week online faculty development program on antennas for 5G communications and beyond. Over the past 6 days, we have been fortunate to participate in a series of engaging lectures, interactive sessions, and insightful discussions. This FDP has provided us with an opportunity to delve deep into the world of antennas, their design principles, and their significance in the advancement of 5G technology. This program did not solely focus on 5G, it also looked beyond the horizon. Your passion for antennas and 5G communications has inspired us all, and we are deeply grateful for your valuable contributions. Now, I request head of the department and convener of this FDP, Dr. N. Radha, to present the closing remarks.
Madam, please unmute your mic.
So thank you, madam. So respected principal and director M. Srinivas Reddy sir, honorable guests and renowned speakers, so learned faculty members, a very good morning to one and all. So I would like to take this opportunity to thank you all for your participating in this 1 week online faculty development program on antennas for 5G communications and beyond, organized by the Department of ECE. So firstly, I thank our chief patron, Dr. N. Satish Reddy sir, Vice Chairman of Aditya Educational Institutions, for providing tremendous opportunities and support for us to organize such FDPs to sharpen our skills in various domains. So this FDP is effectively designed by looking into the requirements of the current RF field in antennas. So I also thank all our eminent resource persons for accepting our invitation and enriching us with their knowledge for improving the teaching learning process for the students and also benefit for the research scholars. I thank Dr. Manish Sharma, Professor, Chitkara University, Rajpur, Punjab, for his day 1 lecture on 5G wireless systems and beyond and research methodology. He also actively participated and was involved in asking questions. So in other resource persons sessions also. So thank you, sir. So for your grateful session. I thank Dr. Nella Avnesh Kumar, Assistant Professor, Bhopal University. Thank you, sir. So I thank Dr. Nella Avnesh Kumar, Assistant Professor, Bhopal University. So for his day 2 lecture on directional planar antennas for UWB and terahertz technology. So I expect, so this session is very, very useful for the research scholars. So I thank Dr. Subbarao Boddu, Assistant Professor, Mahindra University, Hyderabad, for his day 3 lecture on 5G physical layer structure and MIMO channel and space diversity. So his lecture is very, very useful for the research scholars and the faculty who are teaching the antenna course also. And he suggested some of the textbooks also regarding so the 5G communications. So thank you, sir, for your valuable suggestions and for your grateful lecture. I thank Dr. K. Jagdish Babu, Professor, St. Anne's College of Engineering and Technology, Chirala, for today's lecture on antenna applications in wireless communications, a research perspective. So thank you very much, sir, for your valuable session. I think your session is very, very helpful for the researchers, those who are doing their research work in the area of antennas. So with the equal pleasure, I thank our in-house resource persons, Dr. D.V.N. Koteswarrao, sir, so Associate Professor, Department of ECE, Aditya Engineering College, for his day 4 hands-on session on UWB antenna design using CST. So this hands-on session is very, very helpful to the research scholars. So, and I also thank Dr. Tatababu Addepalli, Associate Professor, Department of ECE, Aditya Engineering College, for his day 4 hands-on session on 5G sub 6 GHz antenna design using HFSS. So nowadays, HFSS and CST tools are so very, very important for the research scholars, those who are doing their research in the field of antennas. So I think these hands-on sessions are very, very useful for the research scholars and the faculty who participated in this FTP. So I congratulate and appreciate all the coordinators and faculty members who are involved in making this FDP go efficiently. So thank you all. Thank you very much.
Thank you, madam.
Thank you,
I
ma'am.
request all the participants to turn on their cameras for the group photo session.
Thank you, sir. Now I request the participants to share their views, opinion, or feedback about the program. Sorry, your voice is not audible. I think number P119.
Yes, ma'am. Now is it audible, ma'am?
Yes, madam. Yes, ma'am.
Yeah, good
You may
afternoon to
proceed.
one. This is Dr. VSD Rekha from PVP Siddhartha Institute of Technology, Department of ECE, Vijayawada.
Yeah, madam,
Yeah,
please turn on your video so that if it is possible.
sure, madam. Am I visible to all of you now?
Yes, madam. Yes, ma'am. Yeah.
Yeah. A very special thanks to each and every resource person of this FDP, right from Dr. Manish Sharma, Anvesh Kumar sir, Subba Rao sir, DVN Kotesh Rao sir, Tata Babu Addepalli sir, and Dr. K. Jagdish Babu sir of today's workshop, FDP. I am really very thankful to each and everyone for sparing your valuable time and sharing a very good information which is very useful for not only an experienced faculty and also for beginners, those who are doing their research work and enhancing their research skills in the area of antennas. And a very special thanks to each and every person of this workshop, Dr. N. Radha Madam, Dr. G. Sridevi Madam, Tata Babu sir and Vishnuvardhan Reddy sir for making this event, conduction of this entire workshop and the entire FDP a very grand successful manner, ma'am. And also Mr. Samudrala Naren, who was who has been continuously giving responses to every participant patiently, listening to their queries and immediately resolving each and every query of each and every participant from the beginning of the day to the till the session. So a special thanks to Samudrala Naren. I don't know who is he. And principal of our college who made us to listen a very good session, madam. Really, I'm very happy and being a part of this work. And special thanks to Tata Babu sir for giving practical hands-on session on 5G sub-gigahertz, 6 gigahertz antenna model and UW design by some other person. That is, I'm not getting
Koteshwar Rao,
sir.
sir.
Yes, Kotesh Rao sir. Really, these two hands-on sessions were very useful for all of us, and even for me also, as I was done my research work under this antennas area, reconfigurable MIMO antenna. Though I have done my research work, again I have refreshed all the things and I have brushed up all the things that were covered from the first day to the till day, madam. Special thanks to Jagdish sir, really because of sharing a very good information about metametral antennas and GPR antennas, biomedical antennas. I have noted each and everything what was delivered by Jagdish sir today. Really, I'll make sure that I'll implement the things what are covered, especially today, as these things will be very useful for the application oriented of antennas and to publish very good papers in coming days. A special thanks to entire team, and I'm very thankful to everyone for giving me this opportunity. Thank you all.
Thank you, madam. Thank you so much. Samudrala Naren, he's our faculty member. He's working as an associate professor. Thank you. Thank you,
Oh,
madam.
sorry, sir. Sorry, sir. Okay, sir. Thank you, sir, for giving your wonderful help to all of our participants during this entire 6 days.
Thank you, ma'am. Now I request Dr. Manish Sharma, sir. You raised your hand.
Yeah, ma'am. Ma'am, am I audible to everyone?
Hello.
Am I audible?
Yeah, you're audible, sir, but you're not visible. It's okay, sir.
Yeah, actually, well, it is a really good effort by Aditya Engineering College coming out with the very latest technology on 5G. Actually, I'm very closely associated with Babu. I find very difficult to spell his name always, so I just have a shortcut and I always call him Babu. So that's the way I actually represent him. And moreover, just he asked me whether, sir, can you give a talk on 5G? I told, yeah, this is a very new topic and very emerging topic. Now, what there are a lot of takeaways related to this FDP, not only for the students, not only for the scholars, but I think the teaching fraternity also. Because see, actually, I talked up to I think 2030 in my talk, right? I was talking about 6G. So that was the base of this FDP, 5G and beyond. So there is lot of scope in coming future related to this 5G technology. And if I speak very honestly, in India we have just implemented sub 6 gigahertz band. There is lot need to explore in millimeter wave band, which has been implemented only in a few countries, like the developed countries. If I name them, few of them like Korean countries, and if I talk Japan, and if I name like US countries. So India is very far behind now related to this implementation when the implementation aspects come into picture. Yeah, there is another suggestion for the listeners over here. You can correlate this 5G technology with the like machine learning, artificial intelligence, and all those technologies. In future, it is a requirement actually. Not only like people not talking only about the channel modeling, and we talked about the component modeling over in this FDP. So there is an addition like if as an electronics engineer, if we can nurture ourselves related to this applications like artificial intelligence, machine learning, and I think you can become a very good researcher and you can come out with very not only related to publications, you can go for very you can apply for projects, funding projects, and all those things. So that needs to be escalated, and you need to add few upcoming technologies with this 5D technology. And I'm again thankful to Aditya Engineering College, the management, the department, the all coordinators, the resource person, and really it takes a lot of effort in executing FDP in the online mode. And I'm again thankful to the team, Congrats team, for a grand success. And I'm sure that I assure you, in future FDP, I will one of the participants that can I assure you. And if you invite me as a resource person, I can talk on anything. Okay, thank you so much.
Yes, sir. Thank you, sir. Thank you, sir, for giving such a inputs to the new scholars and the what are the new advancements that are going on in the world. So thank you so much, sir. Uh, any other? Any other participant, if you want to share your opinions or any feedback, you're most welcome. Okay, thank you. As we bid farewell to this enriching journey, I encourage all the of us to during this FDP. Let's implement these learnings to drive innovation and contribute to the development of 5G technology and beyond in our respective institutions or organizations. This virtual platform has allowed us to connect and collaborate with experts and peers from different institutions and backgrounds, expanding our professional networks and enriching our perspectives. First and foremost, I would like to express my heartfelt gratitude to our esteemed organizers for conceptualizing, executing this highly informative and enlightening program. Dedication and hard work have brought experts from diverse fields to share their knowledge and expertise on antennas and their role in shaping the future of 5G communications and beyond. So let us take this moment to express our heartfelt appreciation to all the distinguished speakers who generously shared their expertise, insights, and experiences. Dr. Manish Sharma, Professor, Chitkara University, and Dr. Anvesh Kumar, VIT Bhopal, Dr. D. Subbarao sir, Professor, Mahindra University, Dr. Jagadish sir, Professor and HOD St. Anne's College of Engineering and Technology, Chirala, and our internal resource persons, Dr. TVN Koteshwar Rao sir, Associate Professor, and Dr. A. Tatababu sir, Associate Professor, for their expertise on antennas and antenna software tools. In conclusion, it's an honor to extend my heartfelt thanks to our Honorable Vice Chairman, Dr. N. Satish Reddy sir, for providing a platform to arrange this FDP. And I would like to thank Dr. M. Srinivas Reddy sir, Principal of Aditya Engineering College, for motivating and encouraging us to conduct this FDP. I wish to thank Dr. Suresh, Dean Statutory Bodies, for the guidance for the conduction of this FDP. I thank Dr. N. Radha, Convener and Head of the Department, for supporting for the completion of this faculty development program. I thank Mr. V. Sachinarayan sir, Convener, for smooth conduction of this FDP from starting to this end point. I wish to thank the coordinators, Dr. Tatababu sir and Dr. K. Vishnuvardhan Reddy sir, for their cooperation. A special thanks to Mr. S. Jagadish for the preparation and the arrangement and of online links and certifications. And also thank the organizing committee members for arranging this event seamlessly. And lastly, to all my fellow participants, thank you for your active engagement and enthusiasm throughout this program. Thank you, and may we meet again in even more enlightening and inspiring endeavors in the future. I request all of you to join for National Anthem.
Ma'am, if you allow, I want to speak a bit.
जलधायक जय हे भारत भाग्य विधाता जय हे जय हे जय 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 हे जय हिंद
Jai Hind.
thank you all, thank you all once again.
Thank you, Sridevi
Now
madam.
we-
Thank you for conducting a nice conference.
Thank you, madam. Thank you.
Ma'am, I have one opportunity, or we can say we can have some type of tie-up if you allow me to speak.
Yeah.
Ma'am, we are conducting a conference, IEEE conference over here at Chitkara University. So we are looking for
Yes, sir.
academic partnership. So if you are interested, we can send a proposal to you. So then we can
Right.
talk in detail what does this academic partnership will help out to you as well as for us.
Yes, sir. We'll discuss with our principal, sir, and later we'll inform you.
Yeah.
So meanwhile, we have a discussion, sir. Thank you, sir. Thank you, sir, for giving this opportunity, sir.